Algebra 1, Section 7-1, Multiplication Properties of Exponents. So we got a term here to learn, and this term is monomial. Monomial is one term. This term might have variables. It might have numbers and variables, or it might just be numbers. But a monomial has no variables in the denominator. Right, that's a monomial. So here's an example. A monomial would be 2a, that's a monomial. A squared is a monomial. 46k to the third power, that's a monomial. 10, this is a monomial, but this one we call a constant. Which is a number with no variable. Okay, here are some non-examples of monomials. F plus 24. That's not an example of a monomial. MP over n. We've got this variable in the denominator. This is not a monomial either. All right, now we're going to use these monomials to we're going to multiply them together. So we're going to write here multiplying exponents. And so here's our example. If I have x cubed times x to the fifth power, that's the same as saying x times x times x, so 3 x's multiplied by each other, times 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 x's multiplied by each other. So I have 1, 2, 3, 4, 5, 6, 7, 8 x's being multiplied by one another. 8 x times x times x times x times x, 8 times x to the 8th power. So notice how 3 plus 5 is 8. When I multiply exponents, I add them together. So here's another example. What if I say this? A squared times a to the 7th equals a to the 9th power. 2 plus 7 is 9. So when I'm multiplying numbers with exponents, then I add the exponents together. So here's the rule that I just stated. To multiply two powers, that have the same base, notice how these both have x as the base, these both have a as the base. So as long as they have the same base, you can add their exponents when you multiply the powers together. Let's do another example. This time, I've got 6n cubed times 2n to the 7th power. So in this situation, I multiply the 6 and the 2 together, and that gives me 12. And then I look at the variables here, n cubed times n to the 7th, n to the 10th. I add 3 and 7 to get 10. Let's look at another one. Oh, here's an interesting one here. What if I have n times n? So if I don't have an exponent here, I know that that exponent is 1. So I have n to the 1 power times n to the 1 power. That gives me n squared. Let's do another one. Let's have you do this one as a U try here. 3pt cubed times p to the third t to the fourth. All right, so just take each thing individually, the 3 times 1, p, and then the t's, and write those out. Let's see how you do. Go. Okay, so 3 times 1, I don't see a 1 here, but I know that there's one of these p cubed t to the fourth. So 3 times 1 is 3. P times p to the third, so that's p to the first. So 1 plus 3 is 4, p to the fourth power. T cubed times t to the fourth, that's t to the seventh power. 3 plus 4 is 7. So there's my answer for that one. Here's another one. Let's try this one. Negative 4rx squared t cubed times negative 6r to the fifth x squared t. All right, so if you feel comfortable with this, go ahead and try that one. If not, here we're going to do it together. Negative 4 times negative 6 is positive 24. R times r to the fifth is r to the sixth. X squared times x squared is x to the fourth. And t cubed times t is t to the fourth. So I add 3 plus 1, I add 1 plus 5. There we go. And that's my answer there. All right, let's keep moving here. Power of a power. So this is where this is going to look like I'm doing something different, but, well, I'm doing something different, but hopefully as we move into this section, this won't get confusing. If I have b to the third power, and I raise it to the fifth power, notice I'm not multiplying by b to the fifth. I'm taking b to the third, and I'm raising it again to the fifth. When I do that, then I multiply the powers, b to the 15th. If it was b to the third times b to the fifth, I would get b to the 8th. But this is b to the third 5 times. So really, it looks like this. B to the third times b to the third times b to the third times b to the third, 1, 2, 3, 4, times b to the third. And so when I add all these up together, then I get 15. So that's what's happening here when I go power of power. So here, let's try this one. 2 squared squared. That equals 4 squared, which is 16. Or 2 to the fourth power, 2 to the fourth power, which equals 16. Either way, if we're looking at this rule here, 2 times 2 is 4. 2 to the fourth power is 16. So either way you wanted to do this kind of a problem, you could do it that way. So here's the rule. To find the power of a power, multiply the exponents. So up here, when you are multiplying powers, you add their exponents. When you are raising to another power, you multiply the exponents. Let's do another couple examples. If I have 2 to the third power squared to the fourth power. Now, I want you to write this. I want you to leave 2 the way what it is. I don't want the big answer. I want 2 raised to whatever power we end up with. So think about this for a second. 2 to the third. Okay, so 3 times 2 is 6. and then I raised again to the 4th power, so that would be 2 to the 24th power. 6 times 4 is 24. You try this one. I've got b squared to the 6th power to the 3rd power. So go ahead and try this one. Go ahead, pause and do that work. Let's see how you did. Okay, so 2 to the 6th power is 12. 12, or 2, I'm saying that incorrectly. I think you know what I mean, but b squared raised to the 6th power is b to the 12th power. B to the 12th power raised to the 3rd power. That'll give me b to the 3 times 12. So that's 36, b to the 36th power. All right, we got a few more examples to do and we'll be done with 7-1. Here's another example, negative 2xy to the 3rd power to the 5th power. All right, now this one, notice I don't have any addition or subtraction going on in here. That's very important. If you have only multiplication and or division in here, then you can do what I'm about to do. If you have addition and subtraction, then you may not. When you're multiplying, you actually can distribute this power, this exponent, to the different parts of this term. If there's addition or subtraction involved, you can't do that. So here's what I have. I have negative 2 to the 5th power. X to the 1st raised to the power of 5 is going to get me x to the 5th power. 1 times 5 is 5. And then 3 times 5 is 15, so y to the 15th power. So 2 to the 5th is 32. Negative 2 times itself 5 times is going to give me negative 32. So negative 32, x to the 5th, y to the 15th. Okay, let's do another one. I've got 3 more examples. Here's one that has to do with area. Area of a circle is pi times r squared. So if I have a circle and my radius is 2xy squared, then I say, oh, there's too many variables here. I'm going to skip this one and wait till Mr. V goes over it later. No, that's not what you do. You take this radius and you plug it in for r and you find the area. And you just leave it in terms of the variables. That's okay. Just plug it in for r. So this is what it looks like. I want to find the area of the circle. Pi times the radius, which is 2 times x y squared. And then don't forget that squared. So I've just plugged this in for r. There you go, I'm all set. Now the area is pi, and then I have this, I distribute the 2 in here for each of these parts of the term. So 2 squared, which is 4, x raised to the power of 2, x squared, y squared raised to the power of 2 is y to the 4th power. So now I'm all set. Now I just need to write this, rewrite it in the way that mathematicians want me to write it. And I put the 4 out in front, and then I have pi, and then I have x squared y to the 4th power. And that's my final answer. 2 more examples. Let's have you, let's see. You guys are going to do both of these. U-tries. 2 U-tries. 3xy to the 4th power squared times negative 2y squared raised to the power of 3. And 2a cubed to the 4th power times a cubed cubed. All right, I want you to work on both of these and go ahead and pause, get to work, and then unpause when you're done. Okay, let's see how you did. So I'm going to distribute this 2 in here. So I get 3 squared, x squared, y to the 8th power times, I'm going to distribute this 3 in here first. And so that would make this be 6. 2 times 3 is 6. So now I'm just going to distribute this 6 in here to the y and the negative 2. So negative 2 to the 6th power and y to the 6th power. That just makes it a little bit easier, I think, for me to do it that way. Okay, 3 squared is 9. X squared is x squared. Y to the 8th power times y to the 6th power is going to get me y to the 14th power. Remember, when you multiply, you add the exponents. Now I still have this negative 2 to the 6th power. Okay, 2 to the 6th power is 64. So negative 2 to the 6th power is also 64. So I have 64 right here. And I multiply that by 9. If I plug that in my calculator or whatever, 64 times 9 is 576. And then I've got this x squared y to the 14th power. I'm all good there. Now let's try this other one. Distribute this 4 in there, so I have 2 to the 4th power, a to the 4 times 3, which is 12, times a to the 9th. And then I add these two together. I figure out what is 2 to the 4th power. That's going to get me 16. And then a 12 plus a to the 9 is going to get me a to the 21. And that is 7-1. Good luck on your homework.